This is the fourth of 4 problems I'm doing in this part. This one seems the most wordy of all of them. And like I said with the third problem, actually, this is probably not one, this is not one that I'm going to put on your unit exam. Although it's very doable, and if you take general chemistry, then you're going to need to know this. Let's see what we got. All right, it says 0.285 grams. Well, that's a new one, of oxalic acid. And it goes ahead and says oxalic acid is this guy right here, the 5 moles of oxalic acid. So we have that mass of oxalic acid, 0.2585 grams. Let's see, requires 22.53 milliliters of CHM122. Of course, maybe you remember, maybe you don't, but that's potassium permanganate. So I think I'm gonna do this. There's my arrow. So with regard to potassium permanganate, we got 22.35 milliliters of that solution. Then it says, let's see, what is the molarity of CHM122? So question mark molarity. Again, what does molarity mean? It means moles, in this case, of CHM122 per 1 liter of that solution. Cool, so that's our target. Well, you're like, I don't know where to begin, because it seems like we only know one thing here, and we only know one of 2 things here. But do you see where, if you're given a solid like this, if you're given the mass of a solid, do you see where we can go from grams, step 1, we can actually go from grams to moles of oxalic acid, which is at H2C2O4. And how can we do that? Dun dun dun. Using its molar mass. Everybody loves a molar mass. Okay, so if we get the moles of oxalic acid that way, do you see where now we can go to moles of CHM122? How do we do that? Stoich ratio, baby. Okay, once we have the stoichiometric ratio, in this case we're after molarity, which again, this last step is kind of different for each of these calculations. We can get to molarity simply by taking those moles of CHM122 that we got from step 2 and dividing by the volume, which in this case was conveniently just simply 22.35 milliliters. Excellent. Okay, so for that first step, to go from grams of oxalic acid to moles, we're going to need the molar mass of oxalic acid. You're always going to need to show this step. That's the hydrogen, there's for the carbon, there's for the oxygen, round to 2 decimals. So remember molar masses. If I was going to unpack this number, what that means is there's 90.04 grams of C2H2O4 per 1 mole of C2H2O4. Okay? All right, so we're knocking out the moles. We start with the mass of oxalic acid given 0.2585 grams. What does the next term look like? Well, if we want grams to cancel, be left with moles, it's what I call the flipped version of the molar mass. But you're going to have to show it this way. 1 mole of H2C2O4 poured 90.04 grams of H2C2O4. Okay, so how many significant figures do I round it to? Well, I get to keep 4 this time. How exciting. 0.002871 moles of the acid. Next step is to take those moles now of the acid and go to moles of the CHM122. Ooh, that looks real exciting. So I'm going to put, that's going to be my, oh, I already revealed the answer. Oh, I didn't reveal the answer. Look, it just, my thing got blanked out. Let me pull that up. Looks like this term right here, how silly, should be 0.002871 moles of H2C2O4. Sorry, over 1. Then units of moles of H2C2O4 will cancel. We're left with moles of CHM122, which is great. And notice we round to 4 significant figures. Okay, so our last step, when we've done this before, is simply to take those moles and divide it by the volume that was given. There's my term. Goodness gracious. So we're going to take those moles and divide it by the volume. Now, as we've done before, molarity is not moles per milliliter, molarity is moles per liter. So what's the next term? If we want milliliters to cancel, we're going to put units of milliliters in the top. 1,000 milliliters is equal to 1 liter, put 1 liter on the bottom. Okay, so how many sig figs are we allowed in our answer? I'm liking 4. So rounded to 4 sig figs, we get 0.05138 moles of KMNO4 per 1 liter of solution, or simply called 0.05138 molar KMNO4. So again, the difference with this problem was we were given, we had a solid that we were dealing with, didn't we, as one of the reactants. So, all right, bumping up against an assignment slide. Now, a few things. Remember, I do have hints up on the course homepage for you, but also these odd ones, you actually have the answers in the back of your book. So good luck.